Hello everyone. Let's see how to set up the 8051 microcontroller board that we have designed. So here you can see one board which I have designed, which has a Nuvoton series IC, which is 78E052D W78 E052D. That is the name of the IC that you're using. It is nothing but 8051 core, but manufacturer is Nuvoton. So I guess it is from Taiwan. So this IC speciality is this has a internal bootloader. Okay. So I'm going to use that dip package over here. I'm going to solder it. And apart from that, you can see, let me have a closer look into this board and let you know what and all we are used. Just to look at this, we have an LCD. I have provided an LCD display provision here, and this is our main controller over here. This is the main controller board, main controller IC that I'm going to place, and I'm given a provision for ADC as well in this board, because 8051 core doesn't have an ADC in it, so we have to have a separate ADC on board. So this is actually the ADC, and I'm given a provision for the switches to be connected over here, and also provided a provision for the LEDs over here, and the programming is done serially, which is connected over here. So I'm going to I have provided the bill of material for this board, which is there in the description of this video. So what you need to do is you need to identify the component and solder it onto the board. So usually the IC base is noted as U1, U2, U3, so on, and resistors are labeled as R1, R2, R3, so on. Capacitors are labeled as C1, C2, C3, so on, and jumpers, especially jumpers. So the connectors, okay. So the connectors are labeled as J1, J2, J3, so on. So you have to see which is a better connectors to be suitably we need to put, and we can solder it. So let's see how to solder these components onto this board, and we'll actually quickly flash a program later. So this is the microcontroller development board, and these are the components that I'm using right now for the soldering. So as you can see here, I have included all the necessary components here. Some components are optional, which you can decide if required. So the first main component here is this 8051 controller here, which is W78E052D, and we will insert it through a IC base. So first thing, we need to insert this IC base everywhere. So wherever the IC is required, we need to insert this IC base and solder it, and then we have to use it. Also the connectors. Now let's start inserting the smaller components like resistors, so that it takes the lower surface area on the board. So later we'll include some connectors and all the other components. So there are three resistors here, so which is R1, R2. So I'll just insert these resistors. So you can refer to the bill of material and identify these resistors numbers. I guess here all the resistors are equal value, which is to 2.2 or 1K. So I have one more resistor over here. So okay. So I just insert these resistors first, then I include the IC base, then I will include some pot and connected, so on. So how to solder it? So I'm just going to have a normal soldering gun here to solder this, and I'm using a lead. This is the lead that I'm using, and these leads are already coated with the flux, so I need not have to use a separate flux for this. So let me tell you how to solder this now. So okay, so you just tilt the board, and you are now in the bottom side of the board. Now as you can see here, okay, so this is the board the right now you are using. Let me tell you how do I solder this part. So you have a there is a IC, there is a resistor over here. Now I'll just tell you how to solder. Take the soldering gun. You're supposed to heat the soldering gun. Once the sufficient heat is there, just take this the lead and just you need to I'll do is just hold the lead near the and just apply a little amount of the lead over there. So that's done. Similarly, for the other leads, don't hold it for a long time. Okay. So once you do that, that's it. Okay. Then use this wire cutter over here. I'm going to use this wire cutter. This is the wire cutter I'm going to use. So use this wire cutter to cut the extra the wires that came after the soldering. So cut these wires neatly. Okay, that's it. So now you see the other end, the resistors are mounted. Now let's insert the IC base. So the IC base are labeled as U1, U2 and so on. So what I'm going to do is, so just make sure that the IC base legs are properly aligned. Okay, so you just vertically you see like this, so they should have a proper arrange, they should be aligned in the line. So if not, take a nose player. Okay, this is called as a nose player, and try to make it aligned. Okay, if there is any bend, just correct it so that all the legs are properly aligned. Once it is done, now identify the notch of the IC base. See, this is here is a notch of the IC base right now. This is the notch over here, and this notch supposed to be exactly same what we have mentioned in circuit. Here is the notch U1. So this is my U1. So I'm going to mount this particular IC base over here. Just insert the IC base on one side first. On one side, just try to insert. Okay, I'm inserting it here. So if anywhere if get misaligned, you can just make out that whether it is aligned or not. So once it is aligned, try to align it on the other side. Go to the other side just to move the legs of this IC carefully and try to align it in the hole here. And once they are aligned, you can yeah, now they are aligned. Now you can just force it a little bit, it will fit. Okay, this is the way to fit the IC base. Similarly, if you are using ADC, you need to solder the ADC IC base. So again, identify the notch, align them, insert it on one side, one row, then insert the other row and press it easily. Now tilt the board. Okay, now let me solder this. Okay, so take a lead, you can take some lead. Okay, I've taken this lead. So very easy to solder this. Now what you need to do is keep putting the soldering gun near the pad of this IC base. Just hold it a little bit amount of time, don't hold it for a long time, and just keep soldering it. It has to cover all the area of the pad. Okay, you see here, there is a pad over here, this is the pad, and the lead has to cover all around the pad. So don't leave any side, cover all the sides of the pad with the lead. So once you do that, you can continue the soldering further. Okay, I'll continue the soldering. This will not take more than 1 minute to solder. You can quickly do this. If you find any excess of the soldering on the tip, what you can do is, so you have to use a sponge here. So I have a sponge over here. So this is a sponge. So in the sponge I have added little amount of the water. So you have to clean the tip of the soldering gun. So soldering tip should not contain more of the lead. So what you can just clean the tip by touching the sponge. Okay, just rub this with the sponge and just clean the tip, and you can reuse that again and again. So this is the usual process you need to do every time when you are soldering it. So continue the soldering, clean the tip regularly by rubbing against the sponge. Don't put too much of the lead, put whatever the amount required to cover the pad. So this is one side is done. I'm just soldering the other side. Yes. Yeah, done. So I'm done the soldering. Similarly, I'll do it for the ADC. You just put a little amount and wipe out. This is a skill that you learn when you do this. Done. So I've done the soldering for this. Now IC base is soldered here. So now let me take the connectors. Okay, so as you can see here, I have different types of the connectors. Also, as you can see, there is a crystal. This is a crystal, and let me insert the crystal over here. Q2 is a crystal, and the crystal capacitor 33 picofarad C1 C2 here, another 33 picofarad here. Then let me put the C1 C3 here. This is 0.1 microfarad, another 0.1 C4 here. Then what else? We have okay, LED. So later we'll put, so once there is one capacitor over here, C5. Okay, so I have just inserted these components. Now let me solder this. So you need to tilt it back. If the component should not fall, what you can just turn the bed this bend this legs, okay, so that it will not fall. That's the best way to avoid falling. Yeah, I think yes, that's it. So let me solder this again. Take the soldering lead and just solder this. Clean the tip regularly. So if you are using any old components, if the component leads are rusted, so better to scratch the component leads and then use this for the soldering. Otherwise soldering will not be going to be good. So remove these unnecessary leads. Use the wire cutter. Cutter is better than the stripper. Yes, this part is soldered. Okay, the next element that I'm going to connect is the connectors. So as you can see, there are many connectors. So those who are using this LCD, okay, if you are using this LCD, you will not get this kind of a Berg strip connected to it. So it will be just holes will be there. So what you do is you need to get this Berg sticks over here, this kind of a Berg sticks, and put it inside and solder it. And on the board we will have a female Berg kind of this kind of a Berg will be soldered over here. And once you solder this can be easily connected over this. So that is the method that we use for connecting the LCD. And other connectors, you can use this kind of a Berg strips, okay. You can cut it the whichever length you need. For example, I need actually a 3 Berg strip for this LCD, so let me cut this into 3 leads over here. I'll get only 3 leads. Just put it over here and you can solder it. So you can cut it whatever number. Another type of a connector you get is actually this kind of a relay mate connector you get. So if you, so some places I have given relay mate connectors, some places not, but it is not mandatory that you need to connect only the relay mate connectors everywhere. You can use any kind of connector, whichever you find convenient, use it. So I'll be now just fixing all these components, especially these female connectors, and I will have a bug over here. And let me have a 4-bit connector over here. I don't have, yeah, all 8-bit I will connect it over here. All 8-bit connectors. So see the alignment will be this way. Okay, I will use 8-bit. Here you can use even the single bugs over here. That's also possible. I have it, so I'm going to use whatever available here. So it looks neat and good as well. Okay, I've connected this relay mate some places. Let me connect these bug sticks wherever you need. For example, here I need only 4, so let me just connect it using this 4. So let me just connect it these 4 bud sticks over here. Okay, just cut this. Here also you place around 4 connectors. So this is only if you require. So another 4 over here and another 4 here, 3 required here. Yes, then so these are the place, just insert this and yeah, another 8-bit over here. Okay. So there are a lot of connectors over here. So LED connectors here, who dyed it, and switch connectors. Yes, and yeah, then these are the 5 volts tapping and ground tappings for external interface. So let me connect the switch. So I have inserted all the components onto this. Most of the connectors I've included. Let me solder this onto the board. Solder all these connectors. So after including these connectors, soldering this connector, there is one components left is actually this is pull-up resistors. So how do you connect this pull-up resistors? So usually the pull-up resistor, if you are connecting, there is a mark over here. Okay, you can see that there is a 9 pin. This mark should be you can see this mark over here. There is a mark, there is a white mark over here on one pin that is actually supposed to be given to VCC, and all are parallelly connected to these pins. So it is actually a pull up resistor, so that has to be connected. So there is a provision over here. As you can see, there is a square box over here, or small square boxes here. This square box supposed to be VCC, and rest all is a port pins. So that white mark label supposed to come on the square box, and rest of the pin should be connected, should be inserted inside these holes to the appropriate port pin. So just insert it. Yes, done. So once you insert it, just solder it on the other side. So use the lead. Port 0 does not have the pull up, so we need to use this kind of configuration. Now at any point of time, if you feel like okay, you need to remove some components from this, by mistake you're connected, so what you can do is you need to remove these components. Then I will use, there are two techniques. One is actually this is called as a vacuum pump. So this is a vacuum, so you need to melt the lead on the tip, and in it will, there is a suction mechanism, it will suck the excess molten lead. So I'm using this technique. There is one more technique, it's actually soldering wick, so you can use a soldering wick as well. For that you need to hold the hot air soldering gun near the component pad wherever you want to remove it. Just heat that and just touch this. It will actually suck all the unnecessary, so I can easily take out. But don't do this repeatedly because it may damage the track. So you can clean this later. Yeah, I have actually removed all these LEDs. Okay, so now you see this, how neatly I have removed all the excessive lead. So repeatedly putting the soldering lead on the pad will damage the pad. Okay, so you can use this technique. Another method of removing the component from the board by mistake, if you have inserted or if the component is damaged, then you can remove it by applying with the method of the soldering wick. So this is what the soldering wick is. So this is a copper material. So what you need to do is heat the soldering gun and place the wick over the component where you want to take out that component. So for example, I need to take out this component over here. So what I will do is I'll just keep the wick over the component and just keep the soldering lead on that. So make sure that the tip of the soldering gun supposed to be neat. So you can just rub it against the sponge and make clean it and just melt the component. All the lead that melts will be sticked over this, so you can see the track. You can see that now track is clean. Now you can remove the component easily and you can solder it back with the required component. Once you have this board with you, just what you need to do is to insert this IC. So take this IC and just insert it here. Make sure that your notch and this notch matches, and carefully align the legs of this IC so that you should not break these legs. Don't force it if it doesn't fit inside. So just carefully align it, press both the ends, and you make sure that all the leads are connected to the IC base. That's it. Now in the next video I'm going to show you how to program this. So this IC uses serial bootloader, so I'll be using a serial bootloader application to program this IC.